Hello, my name is Renzo Huber from NIH, and this is an ISMRM presentation entitled Third Order Shim for High Resolution fMRI at 7T. It hurts more than it helps. And I have no financial interest with respect to this presentation. Many of us care about high resolution fMRI, and we are working with data like this. And these data look nice, don't they? They are kind of high resolution. You see how we have multiple voxels across cortical depth. You can see these anatomical features or angio-architectonic features, that we have these large draining veins visible individually. We have these details like the optic radiation directly visible in EPI. And data like this have gotten us very, very far. There are more than 300 human layer-dependent fMRI papers published so far. However, despite all this, they are not quite perfect. It's hard to really put your finger on it because there's not an obvious ghost over there, but still you see that it's EPI. Independent of the distortions you see, it's not like flash, right? We have these shading patterns, like why is this part a bit darker than that part? And we call those artifacts fuzzy ripples. And they become clearer if I make them go away. So here, flipping back and forth, you see that those data that we are used to working with are actually quite corrupted by many, many things. And they can be improved much further. And a very, very simple thing that I did here to improve the data quality was to unplug the third order shim, which has quite a significant effect. And that's the story of the abstract. Data improve if you unplug your third order shim. That's our method resulting conclusion. So we looked at EPI data with and without third order shim. We found that they look better without third order shim, and our conclusion is that people should better disconnect the third order shim. And we thought this is such a strong effect that we better tell all our colleagues about it, and we thought an ISMRM abstract might be a good venue for that. But now we gotta talk for it and need to fill 9 minutes with this. So in the last few months I gathered more data to show you more of the same, that the EPI quality improves as soon as you unplug the third order shim. For example, we looked at different sequences. In the field of human high-resolution layer-dependent fMRI, there has been quite a shift towards certain sequences in the last 5 years. Most of the published papers, in fact, use a 3D EPI readout. And one very popular implementation of that is the DZN-E sequence. And for this sequence, like in any other, you can see that with the third order shim, very often we have these fuzzy ripples, these dark shading patterns. They completely go away as soon as you unblock the third order shim. But there's still a conservative minority out there that still uses 2D EPI, and one popular sequence there is the multiband sequence from CMRR. And also this sequence, as any other sequence, has these fuzzy ripples that go away as soon as you unplug the third order shim. Our vendor friends also asked us to look at this in the stock sequence, where you can always see that we have these fuzzy ripples that go away as soon as you unplug the third order shim. And this is not something that's specific to an individual scanner. We see this across scanners. For example, at NIH, we have 3 7 Teslas available, 2 Tera scanners and 1 70 Plus, and we can see that we always have these fuzzy ripples when we have the third order shim unplugged, and they go away as soon as we unplug the third order shim. And this is not specific to our center. We also ask our friends, for example, Yuhui Chai at Illinois, Urbana-Champaign, and they have their own protocols where they see that they have these fuzzy ripples that go away as soon as you unplug the third order shim. And we have them across all the protocols. Here, for example, you can see that echo spacing has an effect on the third order shims, but they're never really completely going away. For example, you can see here that when you're very close to the forbidden frequencies, they are quite faint, and they become much stronger as you go away from the forbidden frequencies, as strongest here for those kind of echo spacings. And across all echo spacings that we looked at, we always see that image quality improves as soon as you unplug the third order shim. We looked at all the protocols that are being done in our center. Some people try to focus more on visual cortex, some people do auditory research, some people do very high resolution, some people do kind of motor cortex imaging, and we always see these fuzzy ripples that completely go away as soon as we unplug the third order shim. And this is also not specific to our ongoing studies here, also across the entire layer fMRI literature. We looked at these 300 human layer-dependent fMRI papers published so far, and a good chunk of those 300 papers also make their data publicly available. So I looked at every single publicly available dataset, and I find these fuzzy ripples everywhere, in every single dataset, without exceptions. And here you're seeing examples from the top 10 labs that publish most layer-dependent fMRI papers in humans. So if you're not visible here and not shown, it doesn't mean that you don't have a third order shim problem with fuzzy ripples. It just means that you're not within the top 10 most publishing layer dependent fMRI labs, or you're one of those few labs that just don't publish their data. And these kind of fuzzy ripples from third order shims are not only affecting EPI images, but importantly, they also affect EPI stability. So of course, when you have less signal available, your TSNR is also lower. In this case of a specific example of the CMR multiband sequence and these echo spacings used for auditory research from our collaborators, we see that the TSNR drops about 30%. And this means that for a given single experiment auditory stimulation, you might not have activity that exceeds the detection threshold. There is sub-threshold activity, and if you would scan longer, maybe you would also be able to see these activities with the third order shims unplugged. Without the third order shims, you also see it quite nicely in a single experiment. And this is also consistent across experiment and participants. Here, for example, you see that specifically fuzzy ripples are very bad on one hemisphere, where we don't really see most of the Herschel striders, only when we unplug the third order shims. But why are third order shims responsible for EPI problems? Our hypothesis is the following. So these third order shims are embedded within the gradient coils itself. They are between the primary layer, the inner part, and the so-called shielding layer, the outer part. And the winding patterns of these third order shims are very, very similar to the gradients itself. There is this symmetry if it wouldn't be for these inner loops here close to the isocenter. So they can couple inductively, as shown with this little circuit diagram over here, where we have the gradients on the left and the third order shims on the right. And you can see that they form this closed loop over here via the filter plate of the Faraday cage. And the reason why we started to look into this was because Nicolas Boulon has shown previously at their 11.7 Tesla that they have these oscillations in their gradient waveforms when they have the third order shim. Those go away as soon as you unplug the third order shim. But when we unplug the third order shims, we also cannot use them anymore to correct for EPI distortions. So we also tried to see how much we lose in terms of geometric distortions when we unplug them. So here you can see the conventional distortions that we always have in high resolution EPI with the third order shim and without the third order shim. And you can see that the distortions are quite severe, right? However, they are pretty similar with and without third order shims. With third order shims, you just have these additional dark spots popping up everywhere. And this is because most of the distortions are usually caused by this triangular pattern over here, over the nasal cavities and the ear canals. And the available templates that we have that the third order shim can account for in these axial protocols are shown on the right. So the third order shims do not really have the capabilities to account for these distortions that we are dealing with in high resolution EPI anyway. Please also see other software solutions that might be able to mitigate these third order shim problems. For example, on Thursday, I will talk about dual polarity EPI calibration that can also mitigate these fuzzy ripples with a calibration approach. Nan Wang is going to talk about a field correcting Krapper approach that's very exciting, that can also account for these fuzzy ripples. And Ami Segina is going to talk about a different way of breaking these resonances by including specific dead times in his EPI readout. Or you can also use a non-Cartesian reconstruction of your so-called Cartesian EPI. As for practical aspects, you can find more information on how to unplug the third order shim on the blog over here. So you need to reconfigure the system that it knows that it's now a second order system, and then you can unplug them and cover the cable. For simplicity, at NIH, we just have the 70 plus always configured as a second order system. And for our Terra, we have the STX and the PTX separately configured, so you can easily switch between back and forth. So you don't need to do this reconfiguration that requires a reboot. While the science is pretty clear, suggesting that you should always unplug the third order shim, I found that some managing institute directors are sometimes hesitant, and there are some unfounded legal skepticism about unplugging the third order shim. As far as I can say, the FDA status is not affected by unplugging the third order shim. Certainly the protocols are not affected if you reconfigure the system like that. The Zeichnungsstand also doesn't change. Luckily, all these issues with the third order shim are probably a temporary issue, as our friends from the vendors are working on solutions to update these filter plates so we don't have these oscillations anymore. In conclusion, if you think you had good data before, just unplug your third order shim and you will have great data instead. It's incredibly simple. Just unplug the third of the shim and you have an improvement of quality. And in the field of fMRI, this is really a rare thing that we can simply improve things without paying a huge price for it. And with this, I thank our friends from Siemens helping us tracking this down, and I thank you for your attention.